right, I want to introduce you to one more idea and then two short proofs, two short theorems about that idea. So I've got a topological space. X is my set and F is my topology. So we are going to call, oops, let me get my pen here. We're going to call C subset of X closed if C complement is open. So closed sets are those sets whose complement is in fact open. And so let's look at two theorems. Both of these theorems are just getting at how unions and intersections of closed sets work. And the answer is they work exactly the opposite of open sets, and when you see the proof, you'll see why. There's a really clear reason why. So let's start off with a topological space, X and F, and let's say that C1 through Cn, let's let that be a finite collection of closed sets. So when we had open sets and we had a finite collection, we took their intersection, right? The intersection of a finite collection of open sets remains open. Here we have a finite collection of closed sets, and the claim is that their union is closed. So it's opposite, right? And so the proof goes as follows. So if I have this finite union, I need to show that its complement is open. That's what it means for this to be closed. And so I'm going to take its complement, and by De Morgan, this is equal to the finite intersection, I equals 1 to n of Ci complement. Notice it's a finite intersection, and each of these Ci complements is actually open because the Ci's are closed. And so we can say which as a finite intersection of open sets is in fact open. And that's the proof, right? We've proven that this union is closed because its complement is open. And really similar proof, you probably don't need me to write it, but let's go ahead and do it. So I've got a topological space, and let's say, and let C alpha, alpha and lambda be an arbitrary collection of closed sets. With open sets, when we had arbitrary collections of open sets, we took their union and that stayed open. We expect it to be backwards here. And so the claim is that the intersection over all alpha and lambda of these C alphas is in fact closed. And so let's look at the proof. Well, just like before, to show that it's closed, I want to show that its complement is open. So let's look at the complement. I want to look at this arbitrary intersection of the C alphas. I'm going to take its complement, and this is exactly the union of C alpha complement. And exactly like before, C alpha complement for every single alpha, that's open, right? Because each of the C's is closed, their complements are open, and we know that arbitrary unions of open sets are open. So we can say which as an arbitrary union of open sets is open. So we're done. We've shown that this intersection is closed because its complement is open. All right, you should have what you need to work on homework 5.